VSC software suite for the VSC 6000HS now includes a hyperspectral imaging facility which uses the bandpass filtered light source to create an image cube of a document. This cube can be thought of as being many images of a document, stacked one on top of another, each image being taken at a slightly different wavelength. The hyperspectral imager, or HSI, can be activated either from the Tools menu or from the main toolbar. This brings up the HSI control panel, which will be repositioned so we can take a closer look. At the bottom, there are two light source buttons, one for normal flood viewing and one for the bandpass light source. The controls above are similar to the controls used by the bandpass light source. Before the HSI can be used for the first time, it needs to be calibrated. This calibration will be automatically saved and doesn't normally need to be repeated unless the magnification is radically altered. The calibration is necessary to determine the camera exposure for each position of the bandpass filter. To calibrate, we click the Calibrate button, insert a sheet of plain white paper, and click OK. Notice that the bandpass filtered light is automatically selected. Remember to close the flaps to exclude ambient light. The lens may be automatically zoomed in to cover the illuminated area. After calibration, we can go back to the floodlights while we insert our document and close the flaps. To record our HSI cube, we first set the range of wavelengths we wish to use. Use this slider to set the start wavelength to, say, 500 nanometers, and this one to set the end wavelength to 900 nanometers in this case. The full range we could use is 400 to 1000 nanometers. Next, we set the wavelength interval between each image using this slider. The range is 1 to 20 nanometer steps. The smaller the step size, the more images are required, as indicated here. As we are allowed to record up to a maximum of 151 images, we could use as little as 3 nanometer steps, but it will be set to 4 nanometers for now. Finally, click the Record button. With this number of images, the recording takes just over a minute. At the end of the recording process, the floodlights are turned back on. You'll notice that the Play button is now enabled. If we click Play, the live image is replaced by the first image in the recorded image cube. The wavelength slider is resized to cover the recorded range, and the current image wavelength is shown. We can now adjust the slider to scan through the image cube over the recorded range. We can now save the entire image cube and its parameters by clicking the normal Save button. The file suffix is HSI, and the file size could be up to 180 megabytes depending upon the number of images. One of the big benefits of hyperspectral imaging is that we have complete wavelength information for each pixel of the image. To exploit this, we can click on the spectrometer button either here or here. This brings up the spectrometer view, with the image on the left and a copy of the spectrometer graph on the right. The HSI panel is temporarily removed. A crosshair is placed on the image, and the preview graph displays the spectrum of the area at the center of the crosshair. We can drag the crosshair around the image, and the preview graph will display the spectrum at that point. Alternatively, we can click on the image to reposition the crosshair. At any time, we can copy the preview graph to the main spectrometer graph by clicking this button and giving the spectrum a title. Similarly, we can copy the spectra of many other points. If you prefer to see absorption spectra instead of reflectance, click this button and the preview will now show absorption. You can click this button to go to the spectrometer screen, where the usual array of tools are available. click this button to return. When you are finished with the spectrometer function, remember to terminate it by clicking the Finished button. The HSI panel returns, and we can go back to the single image mode by clicking here. You may have noticed the little chromaticity diagram image. If you want to plot a point on the chromaticity diagram when using the spectrometer function, you must ensure your recording wavelengths cover the range 400 to 780 nanometers, as indicated by these bracket lines. We can recall a previously saved image cube by clicking this button. The start, end and step size sliders will automatically be updated. This is a recording made earlier of the same check, but over the range 602 to 816 nanometers. If we now look at the spectrometer, you will see that the spectrum is only displayed between these two wavelengths. All other wavelengths are shown as 0. The one remaining button on the HSI panel toolbar is the Stop button. This can be used to stop a recording or playback function. Finally, when we have finished with the HSI panel, close it by clicking on the cross here or by clicking on the main toolbar button again.